Hello everyone, it's your boy Winswape here, and in today's tutorials we are now going to build our image classification model using Tensorflow. So with this video, I assume that you already have a little bit knowledge about Python programming and deep learning in general. So if you are getting a little bit confused, you don't know anything about deep learning, I recommend you to watch this video from three blue, one brown. Here in this video, we did well explaining deep deep learning and neural network in a way that I can't explain it. It's a very nice video. And also, you can watch this simple image classification model if you just want to get things done very quickly. Here, I built a simple image classification model using teachable machine. But with this one, we are going to use a real Python code. So let's get into the cells and let's run it. And I'll explain along as we do so. So with this first cell, this contains all my imports. So as you can see, I have my TensorFlow and I'm also using matplotlib for plotting certain data out, and I'm also using NumPy too as well. So with this cell contains my data directory. So as you can see, we have this data set. So this is my data set, and within this data set we have the following folders. We have for the pepper and the tomato, so meaning I'm having 5 folders inside this data set directory, and I'm having my hyperparameters. So as we are going to train this model, we are going to pass the image in the form of a batch, and we need to set our image width and height too as well. But since it's going to be in the form of a square, that's why I have my image size to be 180. So I'll use it to represent both my height and my width. And I have this number of epochs also set to be 20. So meaning I'm going to train it under 20 epochs. But with these hyperparameters, you can feel free to change it and see and see the type of impact that you will get at the end of you training your model. So I'm using this. So in this cell, I'm loading the data sets by using image dataset from directory. So it is from this Keras API or from TensorFlow, which we are loading this image from directory. And this, as you can see, the location of my image. And I'm splitting the image. I'm making a subfolder, which is called training. And I have my image size. So I'll pass in for the height, and this one is for the width. And also I'm having my batch size, which is 20. Sorry, which is 32. So let me run these cells. And so as you can see, we have 7,193 images or files, and we are using 5,765 files as our training data set. So this also represents our validation data set. Here in this validation data set, as you can see, we have split it like similar thing that we did for the training data set, but this one is now called validation data set. This one is now called validation because it's for our validation data set, and we have our directories, and also we have our image size, and we have our batch size too as well. So here we are using the remaining four, sorry, we are using the remaining 100 and we are using the remaining 1438 files for the validation. And this is our classes. So let me run this one and run this one too. So we now have our classes to be the names of these folders, as you can see. So we have the paper, which contain this file, and all these files contain images of what you are going to train. So as you can see, yes. So we are doing a simple data visualization. We are just plotting the data to see how, or to see if each and every single image is linked to its class. So as you can see, we have the bacterial spots pepper leaf, and we have the healthy tomato leaf too as well. So let me run this cell, and here too, as we have down here, we are just checking our image batch and our label batch, right? So with our image batch, we have 32 batches, and we have our height and our width, and we have these three which represent the channel. So this is a colored image, it's an RGB image, it's a colored image. So that's why we have three here. So if it was supposed to be a black and white image, then here will be one, so meaning we have only one channel. But with this one, we have three channels. So we are doing data configuration. Here we are shuffling the training images. We are tweaking the training image a little bit and preparing it to be preparing it so that we will be able to train it very well. But with this validation, we don't have the shuffle, but we have the perfect, and we are also doing caching too as well. So if you don't understand all these things, I'll make sure to leave a link where you'll be able to read more about these functions. So we are doing data normalization. So with this data normalization, the RGB is in a range of 0 and 255. But since we are going to use a neural network, we need to make sure that our images is in a range of 0 to 1. So with this data normalization, we are able to process our image to be in the range of 0, and this is 0.99. So let's say almost 1. Yeah. And it does not fall between 0 and 255. So I guess it's cool. So here we are doing data augmentation. Why this data augmentation? Since we are going to train this in a neural network, we need to make sure that the model will be able to see the data from different angles. Like we are doing flipping, which in this case is a horizontal flipping. We are doing random rotation, and we are doing random zooming too as well. So the reason behind this data augmentation is sometimes your model might overfit. So if I talk about overfitness, meaning the model did not perform not just well, but it tends to be confused. But with this data augmentation, the model will be able to see the image from different angles, and from there it will be able to train the image very, very well. So we are going to do transfer learning, and with this transfer learning, we are going to use MobileNet v2. So this cell here will load the MobileNet v2 model for us, and We are going to set trainable to false, meaning we are going to freeze the layers. And this is how we are going to set up the model architecture using the MobileNet V2. Since I said we are going to do transfer learning, so our main focus will be in this output section. Here in this dense layer, we need to make sure that we are passing the number of classes according to what we are doing. The number of classes that we are working with is 5. So I'm having 5 classes. So that is the reason why I'm passing 5 down here. So this 5 represents my number of classes. So if you are working on a project and let's say your number of classes is more than 5 or less than 5, make sure to replace this one with your number of classes. Then with the model, we set our inputs and our outputs. So let me run the cell that I haven't run yet. So let me run all these ones. And let me run this one too as well. And let me run the model. So we are now summarizing the model. So this is our model summary. So there's a whole bunch of models that we can work with. But here we are just going to use MobileNet V2. And before we will train the model, we also need to compile the model. So we need to choose our loss function, which here I choose spark categorical cross entropy loss. We have our optimizer. Here you can choose Adam optimizer, or you can choose any type of optimizer that you want. And just to see how this optimizer is going to impact the final results of the model. And we are also going to keep track of the accuracy metrics during the training section. So we just have this simple callback function, which we are going to use it to save the best score of our model. And it's now time for us to train our model. So for us to train our model, we have this history parameter. So we are saving all our training section in this history parameter, right? So let's train the model. As you can see, we are passing in the training data set, and we are passing in the validation data set, and we are passing in the callbacks and the number of epochs. So the difference between this training and this validation data set is, as the model is training, after going through one epoch, it will take a validation data and then see how well that it did perform while training. And that is the reason why we will be able to save all our best scores inside this callback function. So let's see how the model is training. And we are still on our first epoch. So let's wait for the model to train. So we now have our first epoch completed. And this is the accuracy for the first epoch. So as you can see, this is the accuracy for the first epoch, and this is the loss for the first epoch. And we have our validation loss and our validation accuracy. So our validation accuracy is 95, and we have our validation loss too as well. So this is what I was talking about. So as you can see here, right? So we now have our best code being saved inside this H5 file. So we have our plant model MobileNet v2 H5, and this is the file. So we are saving all our best calls inside this file. So we are now at our third epoch, and as you can see, the accuracy is what, 91, and the validation accuracy is also 91 too as well. So let's wait for the model to finish training and we will continue from there. So our model has finished training successfully and we have now hit our 20 epochs. And yeah, it took much longer than I expected. So this is another way of saving the model. With the first way of saving the model, which was using the callback, we were saving the one with the best score. So with this one too, if you want to save the entire model, which is this one, if you want to save the entire model, so you can use model.save to save the entire model. So let's save the model, and our model has successfully saved, which is plant model.h5 model. And with this cell, we are now converting the entire model. So we are now converting this entire model into a TF Lite model. I didn't use the best score one, I just used the entire model. But that one also worked actually great. So I could have loaded that one into memory and then converted it into a TF Lite model. But I guess this one was very nice. So let's use this one. So we are saving the plant H5 model into a TF Lite format. So this is the name. So here you can change this name to whatever that you want. And I guess it will nicely display here. So let's wait for the model to convert into a TF Lite format. So yes, we now have our model neatly converted into a TF Lite format. But let's run some simple evaluation on our model and see how it did perform. Like we should have even done that one before saving the model, but since I've already go through the code and see how and know how well the model performed, that was the reason why I did it. So first, let's load this dataset image. So I'm taking the test dataset, which I'm pointing towards this directory. So this is a dataset that the model haven't seen yet. So that's the reason why I'm having this one in a separate folder. So with this one too, I'm having 5 classes as usual. And I've now loaded the dataset. So let's run some simple evaluation and see. So as you can see, our model has performed around 98% accuracy in our evaluation in the evaluation process. So with this, let's now plot our data and see how the model or how things are in the graph. Okay, but the graph looks a little bit weird, but trust me, the model did perform very well. So I guess maybe we would then run some tests by using the test data set. So let's do some simple prediction and also see how our results, so that you'll be able to compare it with the graph to see if the model has performed well. So I'm having this function which I'm going to use it to do our prediction, because I want to predict the model with a certain number of images. So I guess building this function will help. So with this function, now we can now plot our images and against its prediction to see how the model did perform. So we have the actual label, which is tomato early bright, and we have our predicted image, and we have our confidence level. So as you can see, actual label, predicted label, and the confidence level. So I guess the model has performed very, very well. It is getting everything as we were expecting. So yes, with this, we can now see that our model is performing very well, even though our graph is a little bit red. But I guess maybe training it with uh, with much higher epochs might bring a little bit changes in the graph. So yes, we now have our TF Lite model, and we now also have our H5 model. So in the next video, I'm going to create a Flutter app which will make use of the TF Lite model. And also, I'll also deploy this model using Fast API, which we will use React application to make use of this H5 model as well. So thank you for watching this video, and I'll see you in the next video.